Now let's properly address the rational functions, right? So in previous sessions, previous chapters, we've looked at polynomial functions and the rest, find domain and stuff. We've done relations and functions where we look at um, various domain ranges of functions. So like we solve a lot of questions there. So here, let's take time and focus on one of the proper functions. That's the rational functions. So what are rational functions? As we say, explain in those times. So I will go again. So in the word rational, right, there is something like ratio. The word ratio. Okay. So the ratio is like we can have like something like 3:5, right? We can have like 4:7. So these are examples of ratio that we made so far. But we can also put it like 3:5 can be 3/5, and then 4:7 can be like 4/7. So they appear in fractions, right? They appear in fractions, such functions that appear in a function such that there is something at the numerator and something at the denominator always, right? But this time we are talking about functions, not just numbers. So rational functions, these are functions that come as a fraction. For example, f of x is equal to 3x plus 2 all over 5x minus 1. So this is a rational function because we can have a denominator, and a numerator part of the same of a function. Okay. So but then to be more specific, when we say a rational function, right? So for you to recognize something clearly as a rational function, what we have to focus on is the denominator. Make sure the denominator is a function of the variable. Okay. So what do I mean by that? Let me give you this scenario where we have, I say f of x is equal to 3x minus 5 all over 2, right? So you might be tempted to say this is a rational function. It's fine because there's a denominator and numerator part, right? Where it qualifies. But then, to be more specific, we need to make sure that the denominator, we have a function such that, or an expression such that there is the variable here is x, right? The independent variable is x. It should be found in the term that is at the denominator. So if I have something like this, right, based on what I explained right now, when you say a rational function, right, cannot classify this as a rational function, right? So you cannot classify this as a rational function. But if you have something like this, f of s is equal to 2 over 3x minus 5. This is a rational function. We can mention this as a rational function because we can see that at the denominator, the denominator expression is containing something that has the x itself. So the x term or the independent variable is found in the denominator, right? That's the major focus. So various variations of that can be anything that you may be thinking of. Okay. So yeah, so that's a rational function in the basic term, right? So we can have f of x is equal to 3s minus 1 all over 4s plus 6, right? As long as there's s at the denominator, right, this is a rational function. So we don't care if something is at the top, right, if the expression is at the top or not. But then the denominator should contain the expression. Then we say it's a rational function. So coming from the word ratio, right? So let's look at some example. So you can see that this is clearly, this is 1 over x is a rational function because you can see that the denominator, there's x expression. The independent variable is found at the denominator. You can see this is also a rational function, that is x plus 3 at the denominator. And this is also a rational function because at the denominator, you have the expression in terms of the independent variable found at the denominator. Right? I have more examples like this. Right? The numerator, we don't much care about it, but the denominator is having an s expression. But if you look at this one, for example, that you can see that the denominator, let me show you something. The denominator here is 1. So if you have a function like this, let me clear this. If you have a function like this, f of x is equal to 3x minus 1, right? So this one is every number or everything that is there like that can also be written at 3x minus 1. There's always a denominator called 1, right? There's always a denominator called 1. Yes, looks rational. This looks rational. But based on the context, the domain in which I'm putting you for rational function to call something fully as rational function, we need to actually see something at the denominator. So that's when we have a rational function. I hope that is clear. So based on the context that I'm giving you, Like, so there are expressions, there are things that say that, oh, all these are rational functions, all right, because there's always one at the denominator. But then the context I'm putting it for you is that make sure that the denominator is having um an expression of x or an expression of the independent variable. Why am I saying independent variable altogether? Because I can give you a function like this: f of s is equal to 3s plus 1 all over x minus 5. So you can see that the independent variable is s, right? Independent variable is a, but that s is not at the denominator. I know we are used to x, 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 but I'm talking about s, just like s as in soccer, right? But then that independent variable is found at the numerator alone. It's only found at the numerator. So this particular expression, right, is not a rational functions because we don't have that independent variable at the denominator, right? In other context, they may tell you that it's still a rational function because every number, like if you just write number two can be written as 2 over 1. So every number is a rational number and all that. I want to clarify you for you to actually see that, oh, this is one is clearly a rational function. For us to be more specific, right? For us to be more specific, that's why I'm saying or iterating over that. So the independent variable should be found at the denominator. So if you have something like this, s minus 1, and then we have something like this at the top, they will rather have x. X is not our independent variable, but s is our independent variable, and we are concerned with other and it's found at the denominator. So this is a rational function. Okay, so now after doing rational functions, there is something called the zeros of a function, right? You need to find the real zeros of a rational function. We'll be using these things mostly. Now, to find the zero of a function, right, what we basically do is that when they give you an expression like f of x, we are going to be using x again. Let's forget about this s stuff, right? When we are given a function and we have to find the zeros of the function, right? Yeah. We are given to find the zeros of that function, right? What you do is that you need to make f of x to be equal to 0. You just equate it to 0 and you solve for it. You do cross multiplication to solve for it and solve for the value of the independent variable or the value of x mostly, right? So in these expressions, right, these ones are here. So basically, if they ask you to find the zero of this particular function, rational function, they are just basically telling you that you need to remove this, and then replace it with 0, so that you can solve for the value of x, right? That's what when we say finding the zero of a function. Okay, let's take it step by step. This one, meaning replace it to 0, and this one to replace it with 0 and solve for the value of x. Basically, that's what you are asked to do when it asks you to find the zero of a function. So it applies to all the other functions that we had too, right? So the same thing, you can just clean this side, this side, this side, and then to write 0 here, change the f of s or whatever to 0. Then you can do cross multiplication to solve for the value of x. That's basically solving for the rational function. So let's start one. So we are going to find the zeros of this one. The first one is 1 over x. So 1 over x, to find the 0, you equate it to 0, right? So that you do cross multiplication, right? You do 0 over 1. So 1 will multiply 1. So when you do that, you are going to have 1 times 1 from the denominator of the 0 is equal to 0 times x. That is going to give 1 times 1 is 1, will be equal to 0 times any number is 0. 1 is equal to 0. This doesn't make sense. 1 cannot be equal to 0. This doesn't make sense. So this leads me to the next thing that I want to tell you, that to find the zero of a function, make sure that that's when you now to if you are asked to find the zero of a function, make sure that the numerator, that's when your focus go to the numerator to find the zero. I'm going to repeat that again. If they are asking you to find the zero of a function, what I explained earlier was if the thing is a rational function or not. If the thing is a rational function or not. That one, you will focus on the denominator to you focus on the denominator to see if the expression is having the independent variable is at the denominator. But if you are asked to find the zero of the function, after you know that it's a rational function by looking at the denominator, now they ask you to find the zero of that function. What you do is that now you switch your mind and focus on the numerator. Make sure now that the numerator is having the independent variable as well. So that's when we are talking about the zero of the function. So if you look at 1 over x, for example, right? This is a rational function. How do you know it's a rational function? The denominator is having what? An expression, or the independent term inside, right? But if you have to find the zero of the function, focus on the numerator. The numerator should have the expression of x in that case, if you're focusing on the zero. So now, in that numerator, if the function does not have the x value, or the x inside the numerator, then you can say that this particular function does not have any zero. You cannot have a zero when there is no uh, expression, and the independent variable is not in the numerator expression. So basically, for zeros, focus on the numerator. But for rational function, focus on denominator, right? That's all you do basically. So for zeros, focus on the numerator. For rational function, focus on the denominator, right? So when you come here, we want to find the zero, so that we focus on the numerator for the zero. So the numerator is just one. It's not having the expression x expression. So for that matter, this particular function does not have any zero. This particular expression does not have a zero. So the same way, if I give you something like, let me go here. No, sorry. Let me go here and clear this side. If I give you, I can give you anything at the numerator, and I ask you to find a zero, right? If I give you f of x is equal to 250 all over s squared minus 4s plus 7, and I ask you to find the zero of this function, you say that there is no zero for this function. There is no zero. There is no zero for the function. Why? Because the numerator does not have the expression. But if I have something like 250 and I just do even x, 250x, then you can find a zero. Then you can find the zero of the function, because the numerator is now having an expression of the independent variable. The x is part, but the denominator, for if you just wanted to focus on if the function is a rational function, then you focus on the denominator. Okay, since that is established, then let's go and solve. Though this particular first function does not have a zero, this particular first function does not have a zero, right? Okay, so what are zeros at all? Zeros are the values of x, right? Or in the independent variable that will make the entire function become zero. That's why when we started, we remove all the f of s expression or t of s or whatever expression here. Then we just say that, okay, let's just change it to zero. So the function, we are trying to find the value of x that will make the entire function become zero. That's why we say we are finding the zero of the function. Okay, now let's solve the rest of the questions now. So we know that this guy is out, right? It does not have any zero. So let's come here, clear this side, and then the next function that we have here is this one, right? So let's solve the zero for this. So it's going to be x minus 2 all over s plus 3 equals to 0. So you do cross multiplication, 0 over 1, right? There's every number that is there, just have 1, right? If there is no the denominator is not explicitly stated. So we do 1 times this. So you have x minus 2 multiplying 1 equals to 0 times s plus 3. So what we'll do is that, yeah, so what we'll do is that now we just solve for the value of x. So we have x minus 2 equals to, this place will be 0, because s minus 2 times 1 is the same as s minus 2, and 0 times anything or any number is still 0. So that will lead us to have x is equal to negative 2, go to the other side, we'll move here to become positive 2, right? So so the 0 it was already here, so let me do it properly step by step. I'll do it 0 plus 2, and the answer 0 plus 2 is 2. So the x equals to 2 is the zero of the function. This is the answer. So the zero of the function is x equals 2. Let's solve the next one. Let's find the zero of 1 over x plus 4. So we are giving 1 over x plus 4. you don't need to proceed to even calculate, because they say you have to find the zero, and the zero is going to focus on the numerator. The numerator is just having one, right? There's no x anything inside at the numerator, right? Then no, so there are no zeros, so no zeros, right? That's what you say. There are no zeros. That's what you do for this particular function. Let's go for the other functions. Okay, now at this stage, I want to, I know how that you have seen the trend already, that the denominator always disappear whenever you are trying to find the zeros, right? Whenever you are trying, because when we were here, you have to use this 0/1, right? You have to use to multiply this. Whatever comes from the denominator here to multiply the zero here is always zero. So we don't basically, so we just focus, we could have just quickly done x minus 2 equal to 0, so that we can solve for it and just have x is equal to 2. That's what we should have done to and find and quickly find the answer. So when you find the zeros of the function, what you basically do is that you don't go through all that process, right? What you do is that you just equate the numerator to 0, because definitely if this one multiplies this, it will still be 0, because 0 times anything at the denominator will be, when you are doing that during the cross multiplication. So the easiest thing to do is to basically just equate the numerator alone to 0. So let's see how we can do that. The function again is, we have x minus 4 multiplying x plus 2 all over s plus 1. We are finding the 0, so you get it to 0, right? So what we do is that we just basically take the numerator, x minus 4 multiplying s plus 2 equal to 0. When we did factorization, we've solved questions like this, right? So what you do is that this is going to be x minus 4, let me clean this, equals to 0, or s plus 2 equals to 0. So then x is equal to negative 4 will go here, become 4, or x is equal to positive 2 will go here, become negative 2. So the answer will be s is equal to negative 2 comma 4, right? Yeah, so these are the answers. So you just arrange it in that order, right? So negative 2 comma 4. So because it comes from the smallest number to the bigger number when we did it in the polynomial function, solving for quadratic function. So that's it. That's the answer for this. So then this one, let me take this one too. Let me clear the board. So we just have x plus 5 multiplying x plus 1 equals to 0. So you can see that this one is, this is a function that they give, but we just equate it to 0. There's no denominator, so we can say equals to denominator 1. But if we are finding 0, we don't care about the denominator, if there is something there or not. So we just quickly go and then solve, continue to solve, equal to 0, or s plus 1 equals to 0. So we have s is equal to negative 5, or x is equal to negative 1. So now x is equal to negative 5 comma negative 1. Remember, negative 5 is smaller than negative 1. That's why I wrote it first. So this is the final answer for this. Okay, now the last one, s plus 2 over s plus 5. Okay, let me clear this. So we have s plus 2 over x plus 5. So if you are to find the zeros of this, you just focus on the numerator. So we s plus 2 equal to 0. We don't care about the denominator. So s is equal to negative 2. So this one is as simple as that. This is the 0 of the function. S is equal to negative 2 is the 0 of the function. Then we are done, right? Yeah, this is how to find the zeros of a function. So I hope by this time you understand what a rational function is. We've taken time to find the domain, the range of that under rational functions. There's a full playlist on rational functions, right? So and on relations and functions. So that one, during that process, we did domain and all that for every rational function. So right now we are just focusing on the zero. So to find the zero, you just equate the numerator to 0 if the numerator is just a constant, or is not having the x expression, or the independent term inside the numerator, then just say that there is no zero in the function. There is no zero in the function specifically. So in the next session, we'll be solving more questions on zeros of a function to solidify the concept. We'll be using concept from the previous session also. So the question will be more elevated than this one. See you in the next session. Let's see how to go about that.